Time for 2.47. Let me apologize for just a second. This problem isn't near as exciting as I thought it was going to be. This is just another run-of-the-mill type of problem that we're going to do, but I think it's worth you seeing. And if you didn't try it, you should try it. This is a problem that's worth giving you, that's worth taking an effort for. The interesting one is in a future section. There's one that has kind of a fun story. There's no fun story attached. This is just water being pumped into a tank. Okay, so a tank is shaped like a cone, and it's an upside down cone, and water is being pumped into it. And the cone has a height of 6 meters and a radius of 2 meters. And so the question is, if the water's coming in at a rate of 5 feet cubed per minute, how fast is the water level rising about 5 minutes later? The key is we have to think of a moving picture, and our moving picture involves our water right here kind of going up the tank. So let's see if I can draw that a little better than I did the first time. So I'm going to have a 6 here for that height, and then let me redraw my tank. Sorry about that. I'm not too happy with my picture. I should be less fussy. Okay. And you all probably look at the rest of my pictures and go, "You're fussy?" And not really. Okay. So what let's do is let's take this tank and let's take this water part of the tank and write it with the height h and the radius r. Now we need to ask ourselves, what is the volume of this tank? Because that's what we're interested in, is the volume coming into the tank. So the volume, now you probably have to look this formula up, but I happen to know it. The volume is 1/3 pi r squared h. In fact, an interesting note about volumes, anytime you have anything cone-shaped, pyramid-shaped, anytime you have a shape that comes down into a point, it's always, you take the area of the bottom, which is pi r squared, the height, which is h, and multiply it by 1/3. So all cone shapes have that same pattern to it. Maybe when you get to Calc 3, you'll do some problems like this and actually kind of see why this works out the way it does. Or Calc 2, I think it's Calc 2 where we do these. Okay, but here's our equation. I'm going to make one really quick note before we move forward that's going to make this equation a lot easier to solve, because if you just attack it now, it becomes a little bit challenging because we don't know the height and the radius. So in order to attack it, one thing I'm going to notice is that if I draw this triangle, I have this triangle right here, which is a triangle of size 6 and 2, and then I'm going to compare it to this small triangle, which is this small triangle right here, which is a triangle of h and r. And what you'll notice is that these are similar triangles. And since they're similar, we can create ratios to connect them with each other. And so our ratio looks something like this. 6/2 is equal to h over r. And there are actually lots of different ratios you could make. But if you remember from geometry class, when you have similar triangles, you can make a connection like this. So this divided by this is the same as that divided by that. We could have done 2 divided by 6 and r divided by h. You could also do 6/h equals 2/r, or h over 6 equals 2/r. But if you take the various ratios, the ratios should stay constant because they're similar. Okay, but this is good. This means that 3 times r is equal to h. But why is that good? That means we can come up here and plug it in, and that's going to make our formula a lot easier to work with. So our formula is the volume equals 1/3 pi r squared times 3h. And let's take even one more step. The volume is, let's take even one more step. Let's write it on the next whiteboard. Our volume, notice our 3 times our 1/3 cancel each other out. And so, that should be an r because our h is 3r. And so all we get is pi r cubed. So that ends up being a really nice formula from one that's a little less pleasant. Okay. So now that we have this formula, we can start to tackle it. dv dt equals 3 pi r squared times dr dt. And now we just have to read our problem carefully and figure out what the different parts are. Okay, so so we know that the water is coming into the tank at a rate of 5 feet per second. So that means our dv dt, that means our dv dt is 5. We want to know how fast the water level is rising, so this is what we want to know. Now we have to figure one more thing out. We have to figure out what is R. And that's going to take a little bit of scratch paper. So let's do some scratch work and figure out what R is. The way we figure that out is we have 5 minutes later, and so 5 minutes later we know how much water has come into the problem. 5 minutes later, 2 minutes later, sorry. 5 is how fast the water's coming in. 2 minutes later, our volume is going to equal 10. So that means I can put 10 into my equation. 10 equals pi r cubed. And so r is going to be the cubed root of 10 divided by pi. And what if I make this a decimal this time? Divided by pi. And cube root of that. I've got 1.47 is my radius. 1.47 my radius. Okay, so now that I have those, I'm ready to get rid of my scratch paper and I'm ready to start solving my problem. So dv dt is 5 equals 3 pi times 1.47 cubed times dr dt, not cubed, squared. Sorry, I'm making a bunch of mistakes here. I guess it's at the end of my sets of problems. So, and then finally, we're able to get our answer. dr dt is 5 divided by 3 pi 1.47 squared. Let's put that into a decimal also. And I've got 0.245. 0.245. And what are the units on this? The units are feet per second, right? Or feet per minute. Feet per minute. All right. So sorry that problem was not exciting or fun. There's no story that goes with it, but it is a nice way. There are a few interesting things that happen. One, our formulas can come in lots of forms. They're not always the Pythagorean theorem. Sometimes they're formulas that come from other places. And two, this idea of using similar triangles, using similar shapes, really makes a big difference sometimes as you move through. So I hope that helped. And that's the end of what we'll do for related rates. Tackle the related rate problems because you can expect there to be a related rate problem on the next quiz. So good luck with that, and I will see you in study hall.